We go with 4.10. We're going to continue finding the value of transformations, but now we're going to do that given a graph of the function. So we'll be given a graph of the function, we'll figure out the transformations that took place, and then try and write the function that would model or create that graph. Let's get some practice in with graphing a couple of functions. First is sine of x over 3. And the second is 3 cosine of 2 times x plus pi over 2 plus 1. I have here a graph for us to use as well as a unit circle in case you don't have yours handy. But remember, in order for us to graph, we want to first find the amplitude, period, midline, any phase shift that's going on, create a table of values for ourselves, make sure we understand what the transformations are going to look like, and then actually create that graph. So go ahead and do these on your own. I'll talk just briefly about the first one and maybe say a few words on the second one, and then we'll move on to some new material. Hope that went well. The first one, the amplitude here is just 1. The period, well, actually, let's get to the period last. The midline is y equals 0. And the period here, this is a little bit tricky. X over 3 is the same as 1/3 times x. So the b value here is 1/3. So my period is 2 pi divided by 1 over 3. Well, dividing by a fraction is the same as multiplying by its reciprocal. So the period, I'll write it down here, the period is going to be 2 times 3, or 6 pi radians, meaning the distance between maximum values is going to be 6 pi. So I won't even be able to get 2 maximum values on here because I don't have 6 pi radians here. So now we need to go ahead and create our graph. We can start plugging in some values here. So sine of 0 is 0, and then we can plug in pi over 2, and if I plug in pi over 2 for x, I have 1/3 times pi over 2, which is pi over 3 times 2, which is 6. So sine of pi over 6 is just going to be 1/2. Oh, there I am. And I can plug in pi, and so 1/3 times pi is pi over 3, and pi over 3, sine of pi over 3 is √3 over 2. And then I can plug in 3 pi over 2, and if I multiply, I'll actually show us this one. So I have 1/3 times 3 pi over 2. 3 over 3 is 1, so I'm left with pi over 2 here. And now I've reached my maximum because sine of pi over 2 is 1, and so here I am at 1. And so if I were to graph this very, very shallow incline like that, it comes down. Okay, and on the other side here, if you could think about, okay, where's this next maximum point going to be? Well, it's going to be very, very far away, right? 6 pi on the other side. In fact, I'm going to have to slowly work my way down and work my way back up and then work my way back to my maximum somewhere over here. Okay, so you could find these values as well. Lastly, I'll just talk about this one briefly. Amplitude of 3. The b value is 2 here, so my period is just pi. My phase shift is negative pi over 2, which means that I'm shifting or translating pi over 2 units to the left, and the midline is 1. So a little more work to do here, but good practice since we're moving on. To get ready for what we're about to do, we want to pick out the key characteristics of sine and cosine, in particular, key characteristics that reveal differences. So you can kind of think of characteristics, and I'm also thinking about differences. Simple differences. So go ahead, spend at least 3 minutes here thinking about looking at the graphs, of course the sine and cosine here. Cosine is in red and sine is in green. And I've also included a unit circle here for you to think about how the values are changing. Just write down some key characteristics that that sine and cosine have that are different. Okay, I hope that went well. So when I look at sine and cosine, and let's just start at the very beginning, at the origin here. Notice that when I plug in a radian measure of 0, sine and cosine are different. In other words, their y-intercepts are different. This is one of the very key characteristics, right? So the sine function has a y-intercept of 0. Y-intercept, which is equivalent to 0. And the cosine function has a y-intercept which is equivalent to 1. Okay? And so notice that the cosine's y-intercept, well, that's its maximum value. Okay? The sine's y-intercept, well, that's at its midline. Okay? Let's also consider what happens after the y-intercept. So let's look at sine first. After looking at the y-coordinate at 0, as I move along my unit circle, the sine values are increasing. So after the y-intercept, then it increases. Then increases. Cosine is different. Cosine starts at its maximum. That's the y-intercept at its maximum. So then it starts to decrease, right? The x-coordinate's getting smaller and smaller. So it starts at its max and then decreases. So these are the key characteristics that we're going to want to consider in order to write functions. We want to think about what will make the most sense in terms of knowing that sine has an initial value of 0, cosine has an initial value of 1, and then from there on sine increases and cosine starts to decrease. Now this will make more sense when we take a look at an example. Here we go. For the graph below, determine the amplitude period and midline, then find the formula for the function. So pause the video. I want you to go ahead and copy this graph down on the amplitude period and midline and attempt to write the formula for the function. I want to see on your paper your first attempt that you did on your own, boxed in, labeled as first attempt, and then I will go over it and we'll talk. I'm sure that went really well. Let's go ahead and talk about the amplitude, period, and midline here. So the amplitude, and actually it's probably best to look at the midline first, which is halfway in between the max and min. And so the minimum value here is -1, and the maximum value is 3. So halfway in between is going to be the line y equals 1. So the amplitude, well, that's the distance between the midline and the maximum, and that's going to be 2. And now the period. So remember, the period is the distance between consecutive maximum points. Well, I don't have 2 maximum points here, but I do have 2 minimum points. And since we're working with a unit circle, the minimum points are always just as far away as the maximum points. So I can look to the minimum points here and see that my period is 4 pi. Now, at this point, I know the amplitude, period, and midline, and I now want to actually write the formula for the function. So go ahead and pause the video and go back and remind yourself of the general form of a sinusoidal function. Write it down and then and then try and fill in the values for yourself, and only once you've tried, press play. So the general formula for a sinusoidal function is y equals a times, now it could either be sine or cosine, so I'll just give us the option here, sine or cosine of b times x minus h plus k. So now let's go ahead and actually try and write this for our particular graph. Well, I know the amplitude is 2, and the amplitude is just the absolute value of a. So let's just go ahead and plug in 2 here. I don't know whether it's sine or cosine. I haven't made that decision yet. Let's see if there's anything else that we can ascertain here. We know that the midline is 1, so my k value is 1. Okay. Now let's also see if we can figure out the b value here. What is the period? Well, the period is 4 pi, and remember the period is 2 pi divided by the absolute value of b. So b, in this case, what must I divide 2 by to get 4? Well, that's going to be 1/2. 1/2 will go into 2 4 times, so my b value is 1/2. Okay, I'm going to have my x here. And now it's time to try and decide what is my sine, whether it's going to be sine or cosine. So go back to the last slide where we talked about the key characteristics of sine and cosine and see if you can tell which one, sine or cosine, makes the most sense here. If I look at my function, notice that it starts at its maximum and then decreases. That's just like cosine. So I'm going to choose cosine. And now let's see if there was any sort of phase shift. Does it look like my maximum shifted to the left or to the right? It did not. So since it's still at the origin, there's going to be no phase shift. I don't even need these pieces here. I did no need for an h value, and so my function is just 2 cosine of 1/2 x. I could also write this as x over 2 plus 1. So what I want you to do is take a second before you move on to this question and write out some steps that you would want to take in order to write out the function given a graph. All right, so based on that last problem, a couple steps. The first thing that I want to do is I want to find the amplitude, the period, and the midline of my graph. Then I want to start filling in my general equation, which is just a sine or cosine, depends on which one it is, of b times x minus h plus k. Okay? The trickier ones to find are going to be the b value, right? That's going to relate to the period. And then deciding whether it is cosine or sine and what your phase shift is going to be. All right? So this will relate back to the key characteristics that we talked about. Okay? Use your key characteristics here. Now, this question says write a sine and cosine function which could produce the graph below. So notice that sine and cosine, they're different, but if I shift them enough to the right or to the left, I can really use either one. So I want you to play around with it. Pick the one that you think makes the most sense first, just by looking at the key characteristics and what happens, and then move on to the second one. So if you think sine makes the most sense first, write a sine function, and then try writing a cosine function. Okay? You should have 2 functions written out, and I want you to then explain where you got your values from. So there should be a brief explanation for how you figured that out, and we will discuss in more detail tomorrow.